Okay. Thank you everybody. Thank you for accepting me speaking here at the OGB tour. Really happy to be able to present once again this topic. My name is Ludovico Caldara. I am an Italian living in Switzerland, and I work for a company named Trivadis. Is one of the leading company providing Oracle services, and not only everything around data in Switzerland. I'm quite active in the Oracle community, co-founder of the Italian Oracle user group. And I'm doing this job since quite a while. It's more than 20 years. I started more than 20 years ago. And I have some passions like volleyball. I'm a very bad volleyball player, but still it's my passion. I enjoy mountain and I enjoy metal, but if somebody asks me, do you like metal music? My answer will probably be, it depends, because there are many genres and I like the very strange ones. So I will not bother you about Trivadis, but yeah, we are 700 employees in the German-speaking region in Europe. So just to let you know that it's quite big, and we do a lot of other services. Also, well, everything that is data, artificial intelligence, projects with IoT, etc. So about the topic would be about client configuration for high availability. And when I decided to prepare the slide deck, I said, what are the problems that I see? What are the problems that I see at customers? Why they're not implementing high availability correctly? So what is missing? And sometimes what happens is that you have a developer that comes to the DBA office and asks for a connection to the database. And the DBA say, which kind of Oracle service do you need? Just give me a normal one. It's a normal Java application. And then the DBA says, okay, then use the default one. And this will be obviously a very bad error, because the default PDB services should not be used. And there are so many things that you can achieve by configuring properly the services and the client, that just using the defaults is not a good idea. And also there is a misconception that if we run our services in a high available configuration like Real Application Cluster or DataGuard, we think we are protected. Well, of course we are protected, because we have either a second node or many standby nodes, and we have a copy of our data somewhere else. But if there is a failure and our application is not ready to detect the failure and act, we can have a problem in the application. So we will see perhaps disconnection. So let's say what a developer, a Java developer, does if he's a newbie and has to connect to Oracle database. And I said, perhaps there will be some developers that just try to connect by following the Stack Overflow answers. And so when I typed on Google Java Connect to Oracle, well, I get this page that is quite popular. And well, we see that there are a few problems. The first one is that it has to specify user, password, everything in the code. That this is not good. It's using driver manager instead of using Oracle data source, the data source drivers that would hide a lot of complexity and but also do much more for us. And another big problem that I see is that the connection itself, besides using an IP address, it uses an SID. Using an SID, it's, I mean, we don't do it anymore. Huh? We have services since many, many years, and an SID is the bad way. But I say, yeah, this is a very old question on Stack Overflow. Perhaps nobody is following with it. But the answer, because the error was class not found exception, the answer was you need to get the Oracle drivers. And you perhaps want to grab OJDBC6.jar, but this is also an old answer. You should not use OJDB6 anymore. There are newer versions. You have to check the compatibility and also the features that offer for your Java version and for a database version. So the topics that I will describe today are quite complex. So I assume that you know already some stuff like the basic high availability concept, what is a failover, what is a connection to the database, and what are like DNS definition, what is a scan listener. And I assume that everything I'm talking about will be at least Oracle 12.2 because this is what Oracle is supporting now, but better if it's even more, even newer than this, like 18 or 19C. And I will talk a lot about failures, and failure is something that always happens in real life and in information technology. And what makes the difference is not if we can prevent the failure, but if we can react correctly to the failure in a manner that will not impact us. And if we can have a completely transparent failure, we will not be impacted and our application will always be online. So what are the factors that influence high availability? There are a lot of layers, of course, starting from the hardware, the network topology, the type and the configuration of the operating system, database configuration, client configuration, and also application design and architectural design of our application. So today I will talk just about database configuration, client configuration, and something about application and exception handling. Just to let you know that there is a very good white paper where I've learned a lot of stuff. The colleague of mine, Robert Bielek, have written a few years ago, and the cover aspect as at the operating system layer as well, like ARP cache invalidation, like TCP timeouts and keep alive and stuff like that. A concept that is really important when we talk about Oracle high availability is the concept of services. So we need to know what services are. A service is like a virtual representation of an Oracle database, a named representation. And when I connect to the service, I don't need to know to which instance I'm going or to which database or region I'm going. What I just need to know is that I'm connected to the right service, and where I connect behind will be handled by the scan listener, for example, or by the configuration that has been made by the database administrator. And I can have active services like we have in the real application cluster, or if we have, for example, multi-master Golden Gate replication, and we can have active passive service. Okay, so this is the basic of the services, and we can have it for a real application cluster or a real application cluster one node, or for DataGuard as well. And how do I create services from the database point of view? So I will explain you also some topics from the database point of view, actually a lot of topics from the database point of view. If you have grid infrastructure, so if you have a real application cluster configuration, you can use servctl add service. If you don't, then you need to use the PSQL package DBMS service and the procedure create service in order to achieve that. Both methods have parameters to configure high availability that I will show you in the next slides. Just to let you know that if I create a highly available services, it's not, I mean, it might be the case that the application still is not able to use it. So there are some configuration that I need to do also from the client point of view, okay? One important thing is that the services, when I create them and I start them, they register to the listener. And one of the old practices that we used to do, but it's deprecated since a while, is to use service names parameter. So if I set service name parameters, it will automatically create a service with the service name of that parameter, but it's better to use DBMS services or servctl services, because I can put some logic in how the services are started, for example, only for a specific role, primary or physical standby, and have, as I said, these high available parameters. So big recommendation, never use SID to connect to the database, and use a service, but not the default one, not the one that is specified with service names parameter, that should be empty, but an application service that you actually want to configure, okay? So by default, you should not, if you have a PDB, by default, you have a service name with the name of the PDB. If you don't have multi-tenant, you will have a service name with the name of the database. You should not use those services, but use your own. And from the connection point of view, what is the connection descriptor that we should use? This is what is recommended by Oracle. And well, it's quite complex if you don't know the syntax, but actually it's quite easy. You have a first part where you have some timeout parameters, some retries that you can specify at client layer. So whenever you have, for example, a connection error, it will automatically retry for a few times after a few seconds. And then I have two address lists. In this case, because I am in a maximum availability architecture configuration. So I have one primary real application cluster, and I see it because I have a scan here, a scan address. And this is the primary one, and this is the standby one. Actually, it's not a good naming convention to call them primary and standby. This is just to show you how it looks like, but you should have site 1 and site 2, for example. And then obviously you have the service name where you connect to. So high availability means that we need to be ready with our client, with our application to react to some activities. So for example, planned maintenance and unplanned maintenance. Let's start with planned maintenance. What is planned maintenance? So imagine that I have one primary database on the left and one standby database on the right, or it can be also instance 1 and instance 2 in a real application cluster. And I have some sessions that exist in my instance because there is they connected through a service that is on that instance. Now, if I want to do some maintenance on this instance, the first thing that I need to do is to relocate the service, okay? So as soon as I relocate the service, all the new connection that try to connect to the service will go to the second instance on the right of the screen. But what happened to the sessions that I have that are already existing on the first instance? By default, they will not relocate automatically. So either there is some intelligence inside the application that say reconnect every now and then, or I can use session draining. Okay, and what is session draining? Is somehow solicitate the sessions to go to the other side instead of killing them. Because if I kill the session, obviously, sorry, I think that I have an automatic. Sorry, there is this automatic switch of the slider is annoying me. Sorry about it. So how can I achieve the session draining? There is a mechanism that is called fast application notification that exists since a while in the Oracle technology. And what it's about a server, an additional server process that I start on the database side that is called ONS, stands for Oracle Notification Service. And the application, when it connects, can also register to the notification service and say, hello, ONS, I'm an application that connects to this service. If anything happened to the service, please notify me. And this is what happened. When I do the relocate of the service, there will be a stop event of the service on the first node, and the ONS will notify all the clients that are registered to the ONS. So the client knows now that the service has been stopped, and they can do something. For example, whenever the transaction is over, disconnect and reconnect. If I disconnect and reconnect, we go where the service is, meaning on the second node. So the client needs to have this intelligence. And we will see how we can automate it or try to put the intelligence somewhere else and not in your code. But to configure fast application notification, I need to have ONS that is there by default if I have great infrastructure. By default is port 6200. And yeah, in 18C, I have inbound notification, meaning that the notification can go directly through the SQLnet connection to the database. And of course, the service where I'm connecting to needs to have a special configuration that where I specify to the service, you need to notify through ONS that the service is not available anymore, for example. And I do it with servctl at service. And I specify this notification true. This activates the notification using ONS. An interesting thing to know that is not in those slides is that starting with the client 12.2, perhaps it's already 12.1, sorry, I don't have the correct information. When you have notification activated at the service level, the client automatically try to connect to the ONS. So if the ONS port is reachable, it will register automatically. If it's not reachable, it will just connect, but will not be notified. Okay. And I also have a parameter that is drain timeout, where I can specify how much time the session can, how much time the session have to relocate alone before they are killed by the relocate of the service. At client side, I need to instruct the application that it has to react to the event. And for that, I need to use the simple fun jar. That is something that you can download from the JDBC driver download page. And I need to create an instance of Fun Manager. So it's a class that manage everything that happened at fast application notification point of view. Then I have to register to my ONS endpoints. And I have to subscribe a new listener. What is doing the listener is the listener that stays there waiting for the notification coming from the ONS. And in this part, I have to handle the event that might be, for example, a service down event. So I can get the event, I can get the reason, and then I can handle it. And what is good way to handle the event is whenever my transaction is over, I disconnect and I reconnect. So I have the time to finish my transaction, of course, if it's not a super long transaction, but normal transaction in OLTP application will be fast enough, and the drain of the session will be fast enough so that the DBA can intervene and do the maintenance on the first node. Then there is an evolution of fast application notification that is fast connection failover. And I try to oversimplify here, but you can think of fast connection failover like putting the fast application notification intelligence not in the application, not anymore there, but in the connection pool. So if I have a connection pool that is intelligent now to manage the fast connection, the fast application notification event inside the connection pool and close and reopen the connections whenever there is a notification, then my application does not need to care anymore about the notification because everything is managed in the connection pool. Of course, here we're talking about connection pool, meaning that the application must be aware that I have a connection pool. So it must borrow and release the connection for every SQL call, for every transaction that it's doing. And this is what we do usually when we have a connection pool. So the connection pool we leverage, if we have fast connection notification, we leverage the fun event to remove the connections after down event. If I have a failure, I can also recreate quickly and recycle quickly the connection. But also, what a connection pool can do is not only to handle a down event, but it could also handle an up event. Imagine that I have many sessions on one server, but at some point my server is suffering, and I decide to start a service also on another instance in the cluster, where it would be nice if the fast connection failover close the connection on the node that is more loaded and open them on the second node. And this is what actually happens if we have some nice connection pool. Talking about nice connection pool, everything that I'm talking about is already embedded. So fast connection notification and this logic and this management is embedded if you use UCP, the Universal Connection Pool, UCP.jar, that we can also download from the JDBC driver download page. And also if we have web logic, we have active grid link, and we can use it to handle fun out of the box. So if you use UCP or active grid link, I don't need to have any code change, just have an application that uses normal connection pool. And I just need, from the connection pool point of view, enable fast connection failover with this fast connection failover enabled parameter. I can also use third-party connection pools. It's possible, it's just some more additional work. My third-party connection pool needs to use a specific driver version, for instance, greater than 12.2, greater or equal than 10.2. Use a simple fun and ons.jar in the class path so that it can plug the connection pool data source inside the connection pool. And in the properties of the connection pool, I have to specify some validation option for the connection, so that whenever there is a borrow and release of the application, the connection pool should check if the connection is still valid. Okay. When I borrow and release a connection, that means that I have no transaction anymore. So whenever I release a connection, well, that connection can be recycled. But UCP and active grid link also think that they can recycle the connection whenever the application calls, like connection is valid, and some other kind of application calls. Because if from the application, I check if the connection is valid, it means that I can tolerate if the connection is not valid. I have perhaps an exception that handles that. And so in that case, the connection pool will close and open the connection for me. So that was for the Java JDBC connection pool, UCP and active grid link, but I have the same behavior for OCI connection pools. So for instance, if I have CX Oracle in Python or OC8 in PHP, and I create a connection pool using oraccess.xml, if you don't know how to do it, check the documentation. It's quite a nice way to have connection pooling also in Python code or OCI in general code. And in odp.net as well, everything is embedded. I just need to activate the fast connection failover using HA events equal true. And of course, using connection pooling. In 18C, there is an improvement that is, how can I call it? The invalidation of the connection happened actually inside the database, starting with 18C. How? Imagine that I have a connection pool that checks the validity of the connection. And if the connection is not good, it will just open a new one. And from the application point of view, I will have no error. But imagine that this connection pool is not intelligent enough to do the job of invalidating the session all alone. Well, from the database itself can detect that the transaction is ended. And if the transaction know that, if Oracle knows that the service is not valid anymore, it can invalidate the session and answer to the client, your connection is not valid anymore. And Oracle can do this automatically whenever I check if the connection is valid using connection is valid, Java call, check connection status, or OCI app server status. But also I can instruct Oracle to say, whenever you see a select one from dual, that means there is a call of validation coming from my connection pool. So if the session has to be drained, just send an invalid message, and the connection pool will open it again. And I can define, so there are a series of predefined statements to do this. I can see them in DBA connection test view, but I can also specify my own queries. So if I want to add the query that matches with the connection validation test from the connection pool, then Oracle will use it as well to invalidate the session and make the drain of the session faster. How do I know if I've implemented the connection pooling properly? Well, I need to test a lot. Try to relocate and see if all the session in the application drain fast. It would be a good idea to implement relocate of services in a CI/CD pipeline, so that for every new release, I'm sure that the application behaves correctly in case of planned or unplanned maintenance. And if my application is ready for planned maintenance, it is a super goal that you can reach in your company, because we can start doing online maintenance in the day. So instead of patching in the evening to avoid the session errors, application errors, I can do it during the day, because I know that my application is well instrumented to tolerate perfectly this kind of service relocate. So session draining is the best solution to hide planned maintenance. Why? Well, I will answer it. Why not? If I have no session draining, that means that my session will persist on the instance where I have to do the maintenance. And that means that I have to kill them at some point. And if I kill a session from the application perspective, this is an unplanned maintenance. This is something that the application is not expecting. So next session is indeed about unplanned maintenance. What is the problem with the planned maintenance? We have the same scenarios that we have seen before, except that I don't need to do maintenance, but the instance actually crashed with all the session in it. So all the sessions are gone, like if I've killed them, they're not there anymore, and the application still doesn't know, because at the next time it will find an error saying your session has been killed, or end of file or communication error, or whatever you get as an error from the application, depending on the type of crash that we have had. So what about the running transactions in this case? Where I've seen in planned maintenance that I can drain the session when the transaction is over. But in this case, we were in a phase, perhaps in the middle of the transaction. So there are a few technologies as well for unplanned maintenance. The first one is transparent application failover. That is kind of, well, I think is one of the most used that I've seen being used by the customers, but it's not the recommended anymore since a while. It works for OCI driver, and what it does is it automates the reconnect at the client level, at the driver level. So the application does not need to reconnect. It's the driver that reconnects all along, the client driver. It allows also to resume the queries and also resume the session state if I have at least Oracle 12.2. But all the transaction and all the PSQL calls are not resumed. So that's why it's not the recommended way anymore. But how it works, just to give an idea, the resumable queries, I'll imagine that I have a session that has a cursor and started fetching the rows. At some point there is the failure, the cursor is lost, and the remaining rows as well. So transparent application failover at client side re-establish the connection automatically, and because I specified that I want to replay the select, it actually replayed the select, the same SCN that I had before, and will automatically open the cursor and discard all the records that have already been fetched by the application, so that the application can keep fetching and get the rows that has not been fetched previously. And I implement it from the database point of view with those minus failover parameters in subctl add services. So failover type select, in this case, I say that I want to replay the select, the delay and the retry, and failover restore level 1 if I want to restore the session state. And still I want to specify notification true because I want that session use ONS so that I can still use FAN and FCF for planned maintenance. I can also specify at client side, I can specify failover, the failover parameters in the connection descriptor. So I can do it both server side or client side, or both of them. Fast connection failover and fast application notification are as well a technology that help to handle unplanned failover. How? Well, if I have two instances and the instance crash, instance 1 crash, the second instance detect the crash of the first instance and can notify all the clients that were registered to ONS and say, hey, the service is not done anymore. Don't try to do any call with your sessions because you can have TCP timeouts. So in this case, again, the connection pool can drop all the sessions and start them again in the surviving instance. So it's still a useful technology. But what is better, and it's new in 12.1, and by new, I mean 7 years old already, it's application continuity. And what is application continuity is a technology that allows the clients to replay the transaction after failure. And it's composed by two main technologies, application continuity. The first one is transaction guard, that is a server-side component. And what transaction guard does is to record the state of the transaction and keep them in the database. So whenever a client asks about the outcome of the transaction, transaction guard can say, yes, the transaction was committed, or no, the transaction was not committed. So the client can retry the operation. And at client side, the client side part of application continuity is the replay driver. So you can imagine it as a buffer from the client point of view, where all the statements, all the calls that I do to the database are registered in this buffer. So whenever I have a failure, the client will reconnect to the database, will ask about the outcome of the transaction. If it was not committed, it will automatically replay the buffer for me and put the transaction in the same state that I had before the crash, so that I can basically continue the transaction. And it has been JDBC only feature until 12.2, where Oracle also introduced this for the OCI drivers. What I have to do from the code point of view, well, if I use UCP, I have no change to do. So again, UCP is the super intelligent connection pooling mechanism that allow me to have all this feature almost transparently. If I don't have UCP connection pooling, that I need to specify from the application that I want to have a replayable transaction. So I have to explicit that I'm beginning a transaction that must be replayable. And I see it here with begin request, end request. Those are the boundaries that say to transaction guard, start register my transaction and stop doing it. So this was from the application point of view. From the database point of view, what I have to do is to activate transaction guard, and I do it with commit outcome true. This enables transaction guard. And from the service point of view, I need to activate the feature with failover type transaction, so that the service knows that it has to behave like a service that allows transaction replay. There is just one caveat, is that when I replay the transaction, if I query the next value of a sequence, I will get a new value. If I set a date, well, I will get the same, well, I will get another date. So I need to preserve the same values that I had in the transaction that failed. And so there is a special grant that I need to give to my application, that is to my application user, that is a keep sequence, keep date time, and keep sys GUID, so that the session can reuse the same values that it had in the previous transaction. So I hope you like it, but what is even better than application continuity now, it's a transparent application continuity. This is a new feature that has been introduced again, JDBC first in 18C and also in 19C with the OCI drivers. And what it does is that record the session and the transaction state server side, including well, everything that I need to do to replay without activating anything from the client point of view. So there is some intelligence in the driver. Of course, I need to have a recent driver, 19C if it's OCI, 18C if it's JDBC, but everything is managed automatically between the Oracle driver and the Oracle database without any knowledge from the application point of view. So all the transactions can be replayed, will be replayed automatically. If there are some transactions that could not be replayed, of course, you will still have an exception, but the cases are less and less with I mean, the more Oracle improved this, the less the number of exceptions will be raised. But there are some effects that can never be replayed, like, for example, what Oracle called the side effects. If I have, for example, REST calls outside the database, or if I have external tables, Oracle cannot guarantee that the data will be the same, and will just raise an exception and will not try to replay the transaction in that case. How do I activate transparent application continuity? I just need to set failover type auto, failover restore auto, and this enable transparent application continuity. Still, I need to have transaction guard enabled. I can also specify for how much my transactions are stored in transaction guard. And of course, I still want to have notification true to have a fast application notification for my planned maintenance. So if it's still not clear, use fast application notification or fast connection failover to drain session and achieve transparent planned maintenance. Use application continuity if you want to have full control in your application code of the transactions that are being replayed. Or just use transparent application continuity if you don't know what to do. It is the best solution that gives you good high availability without changing anything. And I would like to show you a transparent application continuity demo. So this is our training material. What I'm doing here, well, the errors here, I'm just trying to clean something that does not exist, so it's normal that I have those errors. But I create a service and I specify failover type auto, means transparent application continuity. Commit outcome true, means I have transaction guard activated, and I start the service. And I can see it here that I have a failover restore that is out. That means that I have a transparent application continuity service. Now, in another session, is something wrong here? Sorry. Okay, looks like I've done something wrong with the application, but what I can do is I do it by hand, because I can show you this: create the user Ludo identified by Ludo demo effect. Sorry about it. Create session, create table. Okay. So what I do here, I create table A, and I insert like a column varchar 250, and then I insert into no, I have to do it with of course the service. So I will do this to connect to my tax service, but I will just do it as Ludo. And I will insert some data, values, OGB tour. The name of the table was A, perhaps. Okay, so I have my transaction pending. I have not committed yet. And what I see is that I have my session that is not failed over yet because it's still there. And now I will start up first the instance. Okay, it's not a good idea to show this for transparent application continuity. It would have been nicer to have a real application cluster or data car configuration. But this is to show that despite the fact that I have a failure, my transaction should be okay. So now you can see that I have no Ludo session anymore because the instance has been restarted. But if I go here and I do a commit, the commit worked. And if I select from my table, my data is there. So what happened is that transparent application continuity kicked in when I decided to do the commit and detected that the transaction was not there. He replayed the transaction and put it at the same moment where I had the failure. And from the application point of view, in this case, it's SQL+, there is no change in SQL+. SQL+ is always the same. What has changed is the technology that I have activated below the application, meaning the OCI driver that SQL+ is using and the Oracle database. And if I check again, I can see now that the session is there, but it has been failed over. Okay, so it worked quite nicely. Sorry that it took longer to show you this. Well, I had a very nice demo to do that. So time is over, but I will just spend 2 more minutes talking about Connection Manager in Traffic Director mode. There is an addition in the Oracle products from Oracle. So we all know Connection Manager, that is a kind of proxy for instances, for connections. So when a client connects to CMAN, in the normal condition, I would say, CMAN just transparently redirect the SQLNet protocol at a very low level to the database. But if I activate this new model of working of CMAN, that is called a transparent traffic director mode, TDM, what CMAN does is it ends the connection there and start a new connection to the database. Why it's useful? Because if the client connect to CMAN and CMAN connect to the DB will see CMAN as the client, not the original client anymore. And if I have a failure, well, I have a fast application notification that notifies CMAN that something happened, and CMAN has the intelligence to do all the stuff and will reconnect automatically. And if you see in this passage, the connection between the client and CMAN is intact. So there is no disconnection at all between the two. And this is, to me, is a very nice addition to the way Connection Manager works, that allow a better experience for the client. And that's all for me. I don't know if you have any questions.
Ludovico?
Yeah.
You can answer a few questions if you want to in Q&A.
Okay.
You have 2 more minutes.
Okay, I will do that. Then I let you do the pause and continue with the next session. Thank you very much. Thank you. Bye-bye.